Hello, today we are going to talk about the properties of water, or at least some of the properties. I'm sure there's probably a few more. So on the list, I've written cohesion and adhesion, specific heat, solvent or solvent properties, and then expansion upon freezing or expansion with freezing. Beginning with cohesion and adhesion, it basically is talking about how well water will bind to itself or bind to other things. So cohesion refers to how well water molecules are interacting with each other. And this is talking about intermolecular forces. When you put two water drops together, you can kind of see how they sort of cling. Another example of this might be if you see rain running down the windshield of your car or your window, you see how they kind of stick together and they'll even go in the direction of a nearby raindrop, which is pretty cool. So that's cohesion. Adhesion refers to how well water will bind to something else. This oftentimes is thought about in terms of plants. Water is able to stick to like the internal vessels of plants, and that helps them get the water to where it needs to go, which is very important for photosynthesis. Moving on to specific heat, that refers to how much heat or energy can be put into water before it changes temperature. Certain things, will absorb heat a lot. Like think about the leather in your car. If you leave your car in the sun in a hot day, you will notice when you come back, the metal's going to be hot. If you have leather in your car, that's going to be hot as well. Well, water is not really the same case. If you think about the water at the beach, it's very, very, very cold, even in July or June or August. And that's because water takes a lot of energy before it changes temperature. And that's very important for biological systems. We don't really want water to change temperature very fast because 70% of us is water. We want to be able to maintain some type of homeostasis without great change over a wide variety of different heat and energy inputs. Water also has a lot of solvent potential, and what that basically means is that it's very good at dissolving other things, and that's due to the polarity of water. Water is pretty good at interacting with things like sodium chloride, sugar, and a lot of other things, and things like ethanol. Maybe that's not a good example. Other things like, for example, oils are not good at dissolving other things. I guess it really depends on what you're talking about. Lastly, expansion upon freezing or expansion with freezing refers to the fact that water, when it reaches its freezing point, essentially, is a lot more spread apart than it is as a liquid. And you may not think that this really means anything, but when you consider other types of molecules, other substances, when they freeze, oftentimes they shrink down. If you put something in the freezer, it's not going to look bigger than it was when you first put it in there. Well, water's a little different. And that's actually kind of important for animals and things that live in ponds and creeks, other bodies of water, because it allows the ice to float on top. It's less dense than the water below it. So whatever sea creatures or lake creatures are swimming around in there, they're still able to survive and thrive underneath the ice. So this has been a lot of information. I hope this video was not too long, but these are the properties of water. And this is something you should probably try to memorize for biology. And I will see you in the next video.